So this way I don't have to be double screen. I mean, it's great. I can see everything through that. Good.
Yeah. So it should be broadcasting.
We're live.
Is it?
Yeah, I can see.
Okay, you can see it. Then it's fine. So let me see. Good. Good morning from Dubai, or good afternoon, good evening, wherever you might be around the world. We are here at the Digital Innovation Pavilion, hosted by the Climate Change Coalition, IAI Glotcha, together with Evercity, HBAR Foundation, KPMG. And we are bringing digital solutions to this space, to this unique space of global community where the leaders of the world are coming together to work on climate action solutions, accelerating solutions. And we believe that digital innovation has the power to be transformative, really, because we are lagging behind in the implementation of the global goals. So we need new technological solutions, but also social innovations, and digital solutions are enabling social innovations as well. And I'm delighted to welcome today Romy, Sumaria, and Zeina from Terra Quantum, Puzzle, and the Oblique Life, and several other players that are leading this quantum revolution. And we are going to see how quantum computing is helping to address climate challenges, the climate crisis. Romy, over to you.
Well, first and foremost, thank you so much, Miroslav. It's a real pleasure to be here. When I spoke to you about the incredible work that you're doing and the stage you're setting up for UAE this year, I was super sad that I wasn't able to make it in person. However, I think I'm just glad that I was able to join you and all the great sponsors virtually. It's interesting. My journey in deep technology actually started through you in, I think it was 21 at COP in Glasgow, and that was my first experience at seeing the importance of the digital innovation and technology sector in terms of driving climate action. It was there where I kind of saw that it's not just about the technology, it's about the people, it's about the environment, the economy, bringing the whole different parts of the ecosystem all together to ensure that we have this impact that we need so desperately. So yes, thank you very much. And also thank you to another good friend of mine, Alexei Shadrin, who introduced me to you in the first place. It's great to see what you are all achieving. And I hope the quantum element now will become a long part of your mission and your goals with everything you're doing with IAA Glotcha and also the Climate Change Coalition. So without further ado, I'm just going to do a quick introduction to myself, and then I'll pass over to my really good friend Zeina, and then we can get into the agenda. For everyone who's listening in today, I'm Romy Sumaria. Currently the head of business development and partnerships at a quantum computing company called Terra Quantum, but also the CEO and founder of an organization called The Oblique Life. What's really important to me in this journey with deep technology is seeing not just how we can use it and how we can, innovate and think about the application, but also how can we accelerate the commercialization. And that's what we're going to be talking about today. How do we demonstrate what's happening in this industry, in this sector, demonstrate to you as the listeners what's possible in the climate action arena, but also the power of community. So I'm super excited to talk more later. And at this point, I'll hand over to Zeina to do her quick introduction. I think you're on mute, Zeina.
Thank you so much, Romy, and thank you so much, Mira, for facilitating this great conversation. My name is Zeina Jorai-Sinker. I'm a physicist by background, and now I run a technology event and a platform at a think tank called Puzzle X and Matter. It's a pleasure to be here. Romy, back to you.
Thank you very much. And we have a third guest who unfortunately wasn't able to actually join, but he'll have a recording. His name's Joseph Niemela, who's been leading a lot of the work for the International Year of Quantum 2025. You'll hear from him through his video recording, and I look forward to introducing him to the community as well. So in terms of the agenda, we're going to have three different parts today. We're going to talk you through a bit about quantum technology, how we can leverage quantum for good, and some of the applications we're already seeing. Then Zina will talk about the importance of ecosystem and community through the incredible organization she set up called Puzzle X. And then Joseph will share more details on the International Year of Quantum. And I think that will nicely tie together why we're at this incredible stage, the Digital Pavilion, and what we can do together in the future. Let's get to the presentation now, Mira. Great. So I think before we go into the applications, it would just be good to set the context for quantum computing. You see, we look at technological kind of major milestones and innovations. And if we look at the 1910s, we had the real industrial revolution where we went from, our whole way we produce goods and the way we manufacture completely revolutionized. The next big wave, or where we saw the huge kind of inflection point, was the early 2000s with the SaaS world, the internet revolution. I think this is a nice kind of, crossroad between what Miroslav has been doing with his community, looking at how the Web 3 has disrupted Web 2, which was the SaaS world. And that, this whole idea where data is at the heart of everything that we do, the idea that security and protection of this is important, but also democratization of the technology that we have. And that kind of takes us into the next kind of wave. We've seen this year AI has been the story for pretty much most of the deep tech world. But, let's not forget there's other really, powerful exponential technologies that are also really emerging at a fast rate, and quantum computing is one of them. In our eyes, we see this as the kind of next revolution in emerging technology. We're already seeing rapid development from the compute side, from the quantum software side, quantum security side, and the quantum sensing side. So it's a really exciting time. And I think, when people talk about quantum computing, often it's puts you in the kind of movie or some sort of sci-fi novel that you've read about this magical machine that can transform and do things without, any human needed. I think, that's a bit far-fetched, but ultimately we are at the point where we are seeing now there is a real need, usability, and opportunity with quantum technology. So I'm super excited for the next, decades or so, where this is only going to grow. And, just to help people understand a bit about quantum computing, it's not something that's that brand new. There have been greats and scientists who've been talking about quantum physics, quantum mechanics for hundreds of years. People are very familiar, for example, with Albert Einstein, with Max Planck. These are very famous physicists who have not just introduced the idea, but have also set that into many of the things we do, the way we compute classically in the first place. But what really makes quantum computing different? There's two main factors. I think the first thing is, if we look at classical computing today, we're hitting the limit with what's possible. We're hitting the limit because the chips that we have for classical computing, we've got them, we've added as much as we can onto those chips. So there's very little more that we can actually do with them from a compute perspective. The second thing is that when the classical computers operate in binary states, they're either 0 or 1. What this means is that there's a limited ability and capability in terms of what they can compute when we look at very complex problems, when we look at highly large and very advanced machine learning, when we're trying to simulate real natural systems that exist in our world. The second thing is understanding the world from a different paradigm. We want to look, if we can understand the world from a quantum perspective, which is what is the fundamental basis of our existence, then we can actually start really solving the problems in the first principles way, rather than looking at things as okay, this is the best approach we have for this particular part of the problem. So that brings me to quantum computing. Quantum computing is basically leveraging two primary characteristics of quantum physics: superposition and entanglement. Superposition is the fact that in the quantum world, you could be not just in either 1 or 0 in two states, you're in 1, 0, and all states in between. This allows for an exponential capability in compute. In simple terms, you're opening up the solution space exponentially and have way more options within that one calculation. And the second thing is entanglement. It's this spooky concept that's been talked about, and still, quite frankly, there's a lot of discussion and how do we explain it and how do we explain why it exists. We still haven't got there, but at least we know that when you entangle two particles, they could be across other sides of the universe. By knowing what's in one state, you automatically know what's in the other. So these two factors allow for this exponential ability in the compute. And if we can say then to ourselves, okay, if we can translate this quantum particle theory into a compute, that opens up a whole range of opportunities for us to start computing problems that are super complex, like I said, that have massive data requirements, but also that require real precision, accuracy. If we're looking in the medical space, for example, or we're looking at really fine tuning the performance of certain systems. So let's take a step back now, a step away from the depth, and move kind of, what does this really mean when we think of technology? As you probably have been listening to over the last 10 days or so through the Digital Pavilion, we're seeing huge advances in how we've used, for example, blockchain, Web3, how that's disrupted a lot of the way that we manage and think about data, and how it's being democratized. But quantum, in our view, is the next disruptor, in that being that it's going to basically be change the whole way we can compute, and the potential we have for artificial intelligence, for example. And what's really exciting here is that it's not just that it's going to be the next disruptor, it's already starting to do so. The other aspect of quantum computing is, for every advancement we make in what's possible with it, there's also the risk that we face. And this is because a lot of our security systems, how we move our data, how we protect, even the blockchains that we're using that have been built to be super secure, are under threat because the quantum computers can decrypt through these very large, complex codes. Therefore, we're entering a whole new paradigm in cybersecurity in addition, and this is going to transform the way we communicate and the way we move and secure our data. And the third thing is about providing a competitive edge. We've already seen the impact that generative AI has had on businesses and the projections for increase in productivity. Quantum computing is going to be an exponential boost to this on top of that. So not only businesses, but organizations around the world looking at these very complex, again, problems and systems, whether it's even protecting biodiversity, understanding how the planet works, better understanding how different actions will move, how we can predict floods, how we can look at forest fires, all these very complex and very important and damaging natural disasters will be able to be mitigated by leveraging the power of quantum computing. And that's why I am a strong believer that quantum should be really a major part of the kind of journey for how we can achieve good and impact. And there's three main reasons why I think it is now the time to invest and put effort and time into this technology. The first is urgency. I think, as you have all been at COP28 this year, listening to, there's a whole big question about the risk we face of missing the 2030 goals that we set ourselves with the United Nations Sustainable Development Goals. But more than that, if we don't accelerate by 2050, the planet that we live in today won't be as habitable or even desirable for a very large percentage of the population. Just even think about, for example, the fact that 70% of our soils are unfarmable. That says a massive alarming factor, given that we need to feed nearly 10 billion people in this current period. The second thing is responsibility. It's all of our responsibility to think about what we can do. And sometimes it's very hard to take on that responsibility when you don't have the tools that can help you. And that's what we think quantum computing can help with. Is, yes, it's time that we take on responsibility as individuals, as organizations, as nations, but as the world, we need to come together and have a more collective view. And I think that's where my good friend Zina is doing such a fantastic job at breaking down those barriers and boundaries to ensure that we share the responsibility of this important journey. And the last thing is opportunity. I think opportunity sometimes is a word that's forgotten in some of these discussions. Personally, I like to see, even though there's challenges ahead and we're dealing with some really dark times in terms of what's happening on an environmental, social level across the world, there is opportunity. And I think this is where we have to push this forward, because this is where business, investment, and the right stakeholders will get involved. Because at the end of the day, as human beings, we like to do things, and we'll do things when we see there isn't a gain for it. We can redefine a paradigm where it's not just economic opportunity, but it can be impactful opportunity across the board. Now, before, I've probably said a lot of great things about what's potential, but the question then comes in is what problem types can actually benefit from quantum technology? A nice analogy that I've always been shared and told is that, we have to think of quantum technology not as the answer for everything, but the answer for some of the most complex and specific problems. And one to share with you is the fact that if we look at the best classical computing as a bicycle, the quantum computer is an aeroplane. The idea here that it has great, amazing functionality, but you won't use it for very short distances all the time. And that's how we have to think about quantum computing. When you're looking at your problems in the first place, the question is how complex is this problem from a permutational point of view? How many options are there? Is my model that I'm trying to train way too big? Are there too many data points that can't be computed or trained in the classical model? Or on the flip side, I have got insufficient, or I've got gaps in my data. What do I do here? Because I can't, if you haven't got the right collection, this happens a lot in the environmental space. So that's another way to look at things. What is also the impact of this problem? Is it really detrimental to what happens? For example, if we look at the production of and precision farming as one example, we need to get much better at understanding what to farm, how to farm, where to farm, because then we can prolong and improve the life cycle of our soils. We can also improve the yields, but also reduce the pollution that we have with it. So we have to think always about the value and the impact. The complexity, as I mentioned already, that's really important. And when you think about complex problems, we always have to think about, if I'm not able to solve it in its entirety, if I'm looking at a heuristic, as we call it, of the problem, if I'm getting a suboptimal answer, that means there's space to further optimize and improve. And by getting a better answer, we can actually help. A really tangible example I'll share with you right now is in routing, and how we can, for example, reduce empty miles in CO2 by simply looking at big supply chains and optimizing their routes more optimally than exist. The other element is data availability. Now, quantum computing is an advanced technology, and there's no hiding from that. So we also have to think about what data is available and what systems, and therefore, without the data, we're not able to compute. So I think we have to think about all these problems in conjunction. And I think once you do that, then you can see which problems are applicable for quantum computing. Now, I'm going to just share some examples to bring it to life, so you can see where some of the work we've been looking at with Terra Quantum, the company I work with, to kind of give you some insights into where we're already using quantum computing. There's such a wide spectrum, and if we look at the Sustainable Development Goals as a sort of framework or kind of access point, there's solutions across all of the 17 goals. However, I'm going to pinpoint in a few, and hopefully this will bring it to life. And if anybody has questions on the line, please do put them in the chat. We're happy to answer them. I know this is a lot to digest. So the first use case I want to talk about is PV power prediction. As you probably heard at COP28 this year, there's a massive a need for us to decarbonize our energy production and really transition to renewable energy. However, as we know, renewable energies are much less predictable than the non-renewable energies. This is very complex for our energy grids. It creates huge challenges, but more importantly, it can also be very costly the way our grid systems work. Right now, you as an energy provider will provide a prediction of how much solar energy you're going to produce on a daily basis. Now, if that prediction is not as accurate, it's not 100% accurate, or is it a large percentage of inaccuracy in it, there is two things that will happen. As you enter the grid, then, and if the energy, if it's not enough, it's not as much as you promised, then we're going to have to start using non-renewable to make the difference. That is not just costly from the energy production side, but also there's a penalty that these producers have to pay for the inaccurate prediction. With quantum machine learning, we're able to more accurately predict this energy prediction, which reduces this cost, but more importantly, also allows for an increase and true understanding of the yields we're producing from solar energy, really helping scale and move away from the non-renewables, because we know really how much we're getting. The second example I wanted to share with you is in the kind of industrial optimization space. It's not something as sexy as some of these other use cases we look at, but if we think about where a lot of the CO2 emissions that are taking place within society, it's in the big industrial process place. For example, think about steel, one of the most used goods when materials that we have in most of our construction, for our cars, and for every all the infrastructure around us. Now, the blast furnace process itself uses not just a lot of energy, but it's also a highly complex process. What we are doing here is we're optimizing the efficiency of this whole process, and we're able to do so because we can explore and understand the complexity of the system. We use combinations of optimizations and machine learning to do so. And at the end of this, by using this quantum computing for this, we're able to reduce the CO2 that's created from the system, but also reduce the cost for the company. It goes back to that point about impact and opportunity that you can see with quantum computing. The other one I mentioned already is about reducing empty miles. This happens across the logistics system, whether we're looking at air, land, or sea. We have so many goods and people in transit around the world. We need this interconnected global transport system. The question is how to reduce the miles and the distances traveled, but still maintaining the goods and the deliveries to the various points. And this can be done because the routes we have are very hard. When you look at a routing problem for a big supermarket chain, it's a very complex problem. The number of permutations of the best route are so high that a classical computer won't be able to actually compute it. With quantum computing, we can do so. And with that, reduce not only the empty miles, but again, the distance traveled, and again, the economics for the company. Now, if we look a little bit further into the kind of environmental space, a big area, as we've seen in at least from the NLP and the natural languaging process with generative AI, has been how do we look at these large foundational models for understanding natural language? Now, by taking that thinking, we are looking at building foundational models for climate events. It's a hugely new space, and leveraging the power of this quantum machine learning to really understand the way that events are happening around the world for us to better predict and look at the small combining that with the different sensors and quantum sensing, how we can better predict different events that could happen. So for example, for forest fires, by looking at historical patterns of what has happened before, we can have much more accurate understandings of when there could be the next fire by bringing all these different data sets together. In addition, if you don't have data from in one particular part of the world, you can look at similar data patterns using satellite data now, and then you can have that understanding, because we understand that the world systems, what happens in one country doesn't necessarily impact itself. It could impact somewhere else on the planet. The dynamic nature we have in this world. This is going to be hugely powerful and something that I think you're going to see more and more of in the coming years, and an area we're actively exploring and understanding. And then the last thing is, for example, I'll give you is if we think about biodiversity and how we can protect our environments using enhanced classification, image with our machine learning, and looking at simulation of complex systems and biomes, we're able to understand how these places work better to better predict. And so the decisions we make are not just in a linear fashion. For example, we just a lot of the time we'll do one thing for an ecosystem to fix one problem, but then it can have a knock-on effect, creating a few more. With this kind of understanding of the biome, to know where things are, to better predict and better see what's happening, we're actually able to have much longer term protection and can therefore revive and support our natural ecosystems. So the heart of what we're saying is that quantum computing can really have a massive impact, and it's already happening today. I think the message that I want to leave everybody here with is that the journey for you in quantum computing may be early, you may be advanced, whatever you are and wherever you are on the stage. The question is not about if it's going to happen, it's about when and how can we leverage it. So I encourage everybody here to start, if you're in certain businesses or sectors where you're facing complex problems, where you're looking at where you're interested in what this can do, to reach out to myself, to people like Zena, to Joe, anyone else in the quantum computing communities around the world, to see how you can be on the journey. And the last thing I'll finish with as well is that this is really an exciting space, and I really look forward to working with Miro going forward, and really building this into the digital pavilion in future years. Thank you. I'll now hand over to my colleague Zida, who's going to talk more about the power of ecosystem and community. You're on mute still, Zina.
Thank you so much, Rami, for the great introduction to quantum. And now I'm going to take a different spin on this and allow me to share my screen. And I am going to talk today about the age of exponential technologies, which is providing us for a new avenue to look at different ways of doing global collaborations, truly. We are entering a new age at the history of humankind. We're entering a new age of exponential technologies where we have, with the development of certain areas of knowledge for humanity, have reached a certain level of maturity, such as machine learning and AI, such as quantum, so genomics, and frontier materials and nanoassembly. These 4 areas have now reached a certain point of maturity where they soon are not going to only be aiding one another and accelerating one another, but they're actually merging into one another, where they're creating different areas of hybrid development. No longer climate is separate from quantum, no longer music is separate from biology, no longer materials are separate from fashion. These things are all connected with one another. And the more we have a bigger picture of this and a bird's eye view of what is happening, the better we're going to be able to take advantage of these exponential technologies. The thing is that at the age of exponential technologies, with this exponential development, it is not only about the hybrid areas of development that are popping up. It is actually the fact that the speed of development is so dizzyingly fast that it is extremely difficult to stay abreast, to understand what are on the horizons and who to collaborate with and how to bring the most value and benefit from. And that is going to be the differentiating factor between us taking true advantage of the potential of these technologies and doing just well. And one of the issues that we have right now with the way that we collaborate in different fields is that different fields are very isolated and they're in silos. For example, the folks in health, they do not necessarily talk with the folks in nanomaterials, or the folks in governments do not necessarily talk with the folks that are in quantum investment. And these silos are stopping us from taking real advantage of this exponentiality of technology. And it is time that if we really want to take advantage of this, then we need to be bringing the pieces of the puzzle together, and we need to be able to look at the big picture and the bird's eye view of what is happening. And that is a very, very tricky thing. It's much, much easier said than done. But truly, it is a feat for us to be able to bring the different pieces of the puzzle and different communities together to speak the common language, to sit around each other and understand what they can do, how to leverage the power of exponential technologies for a more prosperous and sustainable future. And that is the reason why we started PuzzleX. And I'm going to show you a video, and hopefully the sound plays.
This is the start of something new. This is the start of a community, our community.
And that is the reason why we created a different collective. We created a different community and avenue for people to come together to create a different way of interacting with the biggest thought leaders in the world. We bring together 3,000 stakeholders, and we did that just in November 7 to 9 in Barcelona, where we had the pleasure of having Rami and many of the stakeholders in our field coming and joining together. 3,000 stakeholders, 64 countries, 52% of them C-suite and senior decision makers. policymakers, all coming together to take advantage of the potential of exponential technologies and what that means for the next chapter for cities, citizen industries, and societies. And how can that contribute to building a better, more sustainable future, as well as a prosperous world. And this kind of activity requires a different model of convening and a model of interacting and collaborating. One of the things that we did to bring the stakeholders around quantum together was that we convened around something that I would like to introduce. And obviously, Joe, after this, with his video, we're going to be taking advantage of his remarks in that, is the International Year of Quantum, which is a proposal to the UN General Assembly to proclaim 2025, the year 2025, as an International Year of Quantum. What we did as a part of the Puzzle X Collective was that we brought together and convened the Quantum Key Stakeholder Assembly on November 9, where we came together and collectively we sat together in different working groups, and we started looking at what would be the recommendations for us to prepare for the opportunity of this resolution getting passed by the UN General Assembly, and how we can actually contribute to this, so that in the year of 2025 we'll be able to really join forces and use the power of quantum and quantum science and technologies to advance SDGs and the United Nations Sustainable Development Goal agenda. And with that, I'm going to actually close this conversation. After Joe's video, Romy and I are going to be taking a little bit of a deeper dive into how you can get engaged, how we can welcome new members of our community. And here there is the QR code. If you would like to connect with me, feel free to drop me an email or drop me a message, and we'll be in touch. Thank you so much, Romy.
Romy, you are muted.
So I was just saying how great you are, Miro, and how it's great that you and Zina are now coming together with these ecosystems. I think this is what we need more of. I think, as we said, we'll have unfortunately, Joe is traveling this morning, but we did want to ensure that he could share some of his thoughts and give the people some more ideas about what this International Year of Quantum is. So over to Joe Niemela. Thank you. Have you got it? Can you hear it, Miro? Miro, is it playing on your side? Oh.
You know, Romy, if the video does not play, we could pick it up.
Yeah, sure.
Joe is.
I think I've got it ready as a.
You know,
backup.
Romy, if the video does not play, we could pick it up.
Yeah, I've got it as a backup here ready. 1 second.
Yeah, it worked today before, but okay, you have uploaded it. Now let's try with this one. No, still no. Is there any setting that you have to share sound as well? No, I don't think so.
If we can't make it happen, Romy, we can present what Joe is going to say anyway.
Okay, sure.
I think it will be necessary.
Sorry, I thought I can hear the audio on my side, but yeah, I think we'll just go ahead without it for now.
Romy, just one last try. You know, when you are presenting, there is when you share screen, there is a button that says also share the tab audio. Did you try that one?
Yes, 1 second. Zina, maybe you want to start by just giving some thoughts on this while I get it up quickly.
I can certainly do that. So let me then introduce this fantastic collective effort, which is the International Year of Quantum. There is currently a UNESCO recommended a resolution that is going to be going to the General Assembly of United Nations to proclaim 2025 the International Year of Quantum. And it has been backed by 57 countries, led by Mexico. And we're very excited about the advances for this. It's been a collective effort from ICTP and a lot of the different partners that have come together from scientific societies that have been leading this to take it to this point that we have right now. And if this this year this resolution passes in the United Nations, the 2025 is going to be a very great opportunity for all of us to raise the profile of quantum science and technologies. And it is not going to be only for the countries, the developed countries or countries that have national agendas around quantum, but this is going to be a unique opportunity for everyone, students, citizens, industries, governments, from the global south to the developed countries and to underdeveloped countries and developing countries. They're all going to be able to come together and learn about what quantum is. There's going to be thousands of activities going on in this year 2025, collectively led by a grassroots effort, but all of the members of communities such as myself, Romy, many thousands of other people, thousands of the people in the collective that are going to be engaged in this. And what we are doing as a part of this community is that we are laying the foundation for a very vibrant year in anticipation that this will be passing through General Assembly, hopefully in the next 6 months, 4 to 6 months. And at that point, this does not belong to only the quantum community. This belongs to the entirety of the globe, so that we encourage everyone to get engaged with us, to join forces. And it is as an opportunity for everyone to be quantum educated and to also understand how to leverage the potential of quantum for their own sector and for their own countries and region. And a part of that, to be able to connect with us, is an easy way is for you to as we've done with the PuzzleX Quantum Collective, is that we have convened a community of leaders, community of quantum stakeholders who have been coming together, preparing recommendations, understanding what are the opportunities and potential for getting engaged. And you can do the same thing. You can be a part of this quantum collective. To do that, just message me or Rami or Joe, and we'll be able to enter you. We will be welcoming you to the community and keeping you updated on the development. And once we have the International Year of Quantum, fingers crossed, everything passes in 2025, then we'll be launching many different activities that you can be engaged in your own region, in your own country, in your own industry. The success of an international year proclaimed by the UN is in the number of the stakeholders in a grassroots effort that get engaged, that do something and lift that and raise the profile of quantum science and technologies for a better world. Rami, now back to you. I think we didn't get Joe's video, but I think that we presented a bit.
Yes, no, amazing. I think thank you for stepping in there. Just the joke is always that you work in quantum computing, but basic technologies never seem to function. But anyway, we're okay. I think we're all good. So look, it's been, this is just the beginning of the journey. And as I said at the beginning, I met Miroslav a few years ago, and at the kind of middle part of his journey, should I say, and what he's doing with the United Citizens Organization through his various communities is very aligned and similar to what we're doing in Puzzle X and the collective here. So yeah, I think you've already shared how people can get involved. So please, like as Zina said, get in touch. And I'm going to hand it back to Miro now. Maybe Miro, if you had any questions for myself or Zina that you just wanted some more further clarity on.
Naya, first I would like to congratulate you for your leadership in looking how these emerging technologies can be harnessed for the common good on the local and global level. It's very important because it does not come automatically that these kind of technologies benefit the public. There need to be people who see the potential and then make a plan and develop the solutions in this field. And so congratulations for your work that you are doing in this field. I wouldn't go into too much discussion and details about quantum computing because I'm not really yet so knowledgeable about this. But on your journey of making quantum computing relevant for the SDGs, you can count on us. You can count on the Climate Change Coalition, on GLOCHA, and also the technological and institutional infrastructure that we are building. Romy, as we have been on the journey together with the United Citizens Organization, we will try to really channel all the resources in the meaningful and positive uptake of quantum computing for the global community. And yeah, no further questions, just congratulations. But any other questions? Christina, you said you are very interested in quantum computing, although not techie.
I'm so low tech you can't believe it, but I'm a devout lover of quantum physics. So that brings me into, I can jump into the space and I'm understanding it. And this is very, very exciting. But I need to kind of understand more. Zina, she's amazing. I mean, this was a beautiful presentation. Thank you. I mean, this has really kind of opened my head a little bit. Thank you so much. This is
please do get in touch with us so that we can welcome you into our community and to understand better what are the opportunities in the quantum space for anybody who is carrying the torch for a more prosperous and better future.
Sure. Hi, I kind of walked into this presentation not knowing what to expect. I love the fact that you're tying it into climate tech and you've got some examples about agriculture. So in my application, I've been trying to figure out where we go. We measure soil, we analyze soil with nuclear spectroscopy. So where you normally sample soil, I think, you know, in terms of grams, we measure it in millions of cubic meters. So we have all this data. We're wanting to know where we can go with it. And I guess your point about where do you collaborate? Where do you start? Where does somebody like me start to make a connection here? Maybe I've picked up a little bit of that from this presentation. So thank you very much.
So I think that these are some fantastic points. And for both of you, I think the interest, I'll take them one by one, I think, just to quickly address them. Interest is the first step to the journey. And I think that's really important. But more than that as well, you know, Zina and I talk a lot about how do we look beyond the developed world and places where there is a lot of access to information, access to technology, access to resources. So that's why working with Miro and seeing what he's done with GLOCHA and seeing what he's done with the Climate Change Coalition, Digital Art for Climate, these are initiatives we're bringing in to make sure that we also look at how we can spread information to parts of the world that are not on this journey yet, but will definitely be interested. So I think it's watch this space, but that's definitely coming together. And then in terms of the data you have, I mean, that's a super interesting starting point for a quantum opportunity. And I think, you know, we'd love to explore it further and can share more thoughts on how that could manifest into something and usable, given the importance of what you're doing.
And if I might add to this, as you mentioned, the last question that we had, one of the avenues is to get engaged with the quantum ecosystem, not in a way that is going to be daunting, but come and be a part of our collective. We are going to be hosting another Puzzle X, which is going to be quantum is going to be one of the pillars. One of the 3 pillars of the Puzzle X 2024 is going to be quantum. We're going to be convening hundreds of the quantum key stakeholders from the companies, startups, and enterprises that are involved in quantum computing and quantum cryptography, quantum sensing, that are going to be gathering. And the interesting and very unique thing about what we do with Puzzle X is that we bring them together. We bring these stakeholders together and we say, we are not going to be talking jargon. We're not going to be talking about anything technical. And Robbie knows this very well. We do not have any technical talks at our events. We talk about how do we actually bring the messaging of quantum to the people who want to understand what quantum can do for them. So I encourage you, if you're interested, send us a message, me or Robbie, and we'll extend an invitation for you to be a part of Puzzle X 2024, especially in the quantum section of that, so that you can ask those questions and explore in the 2 or 3 days with these quantum stakeholders.
Yeah, thank you so much. I think she actually answered part of my question, because I was looking for entry points. Unfortunately, I missed the whole presentation. So I work at the European Space Agency, where we build satellites and have loads of data. But I was wondering if in our division, at least, we're not yet looking at what quantum computing for Earth observation data. So I was wondering if you're looking at this and where to get more information, even about your presentation, because this is an untapped potential that we need to look at. So if you're aware of any entry points, I would be more than grateful.
Absolutely. I mean, it's so exciting that you mentioned that, because a good friend of mine, Polizois, who's based at the European Space Agency, has actually been in. We've been exploring and discussing a lot of topics around quantum computing, quantum security, quantum information. So if you get my details from Miroslav, I can connect the dots for you and bring you in. We can also share this presentation with you afterwards. But just to give you a flavor, Earth observation satellites are actually at the heart of there's a fantastic quantum solution. In fact, we did a project with Thales, the space agency, with my company TerraQuantum, where we optimized the satellite mission planning and the ability to have to better order the photos that are taken of the Earth during the satellite's orbit. So I can share all those details with you. It's already happening. The movement's there, and I think space, quantum, this intersection is just it's just beginning, but there's so much that's going to come from that. So really excited about it. And I know Zena as well is involved with a lot of different people from the space agencies across the world.
I was literally 2 weeks ago, I was at a panel in Barcelona for the Quantum for Space. And I talked with a lot of folks from ESA and NASA that are involved in quantum. Quantum in space is actually a very thriving sector. So please send us a message and we'll connect you with the right folks. And also we'll extend an invitation for you to come to the next Puzzle X, where that is also going to be one of the key topics, quantum and space.
Amazing. Thank you so much. Thanks a lot.
Can I ask another question? I want to ask another question, because Puzzle X really I was drawn to it, but I'm wondering, is there a way in for the arts, humanity, and culture in this? Because quantum is an intuitive. It's kind of a spiritual avenue for a lot of people. So, is there an avenue in from that? Because I didn't see that in the Puzzle X.
100%.
Over to you, Zena.
100%. Last Puzzle X last month, we unveiled a project which is native to Puzzle X called the Quantum Symphony of Biology. We use quantum computers to actually unearth the patterns of software of a stem cell that is turning into something else, and we realized that there was a music and sonification in it, and we use quantum computers to do that. We have a very thriving quantum arts and music community at the part of Puzzle X, and we would love to welcome more.
And I think you have a great question. I mean, we didn't touch on it when we're thinking about quantum for good, because there's so many different aspects you could go into. But I think Zena's, at the heart of one of these communities. There's also a few more out there. There's one called Hollow Art, led by Mariam Bryan, and then Sadegh Elbrahimi, who have also driven. And there's plenty of art for quantum movements that are happening across the kind of world now. And I think this intersection will only increase as well. Just as we've seen digital art for climate, we've seen Miroslav has been leading the blockchain NFT art for technology. How do we bring that all together? It's a matter of time. But like you said, there is that deeper kind of connectivity between how we look and how we think, how we process. There's a lot of work happening on understanding the way our brains work, and mapping brain waves and understand and stimulus into art and different visualizations. So watch this space. It's definitely growing. But I guess want to put one caveat, which is behind all of this, and the way we always look at quantum computing is that the options are endless. The question always comes down to where can I have the highest impact and what's most important. And that's just something we always say, because humanity's first, and therefore how do we support what's needed, rather than getting carried away sometimes in the kind of amazing opportunity and rabbit hole that you can find yourself in.
Thank you.
Congratulations.
Thank you so much.
Thank you, Miroslav. You are a true hero, my friend. Keep up the amazing work you're doing. Keep driving community and keep making the world a better place. Thank you.
Thank you very much
for the opportunity.
Pleasure with such great companions. Good. Thanks. Bye.
Bye.